In today's video, we're going to look at finding quantiles from a normally distributed population. We're going to use an inverse standard normal table to find a quantile, and then we're also going to use our graphing calculator. And then lastly, we're going to be looking at applying our normal distributions to some of our real-world problems. So to begin with, we're going to start with the following real-world problem. I'll give you a minute to read it. So we want to look at the population of crabs. We know it's normally distributed, mean 70, standard deviations 10 millimeters. Biologists want to protect them, so they're only going to use the largest 5% of the crabs. So he asked the question, 95% of the crabs have lengths less than what? So we need to figure out what this is going to be. So in order to figure this out, now I'm giving you a probability, and we have to find the actual value. In the past, I gave you a value and you found the probability, so we have to go in reverse order. So to begin with, we're going to be looking at, well, what value of k is the probability of x to be less than or equal to that, equal to 0.95. So in order to do this, we are going to look at an inverse normal table, or we're going to use the inverse normal on your graphing calculator. Here is an inverse normal table that we'll be looking at. So this is part of where we're going to be finding values. I'm giving you the probability now. Keep in mind, please, that the probability is from 50% up through 100%, or 0.999. So I don't give you any of them where the probability is less than 50%. So if that's going to happen, you're going to have to use the symmetry piece to help find that. So we're going to look here at doing an inverse normal. So I want to find the k value when the probability of x occurring is less than or equal to k is 0.95, given that x is normally distributed with a mean of 70 and a standard deviation of 10, and x is measured in millimeters. So what I need to figure out is I need to look at the fact that I need the probability for my z-score to be less than or equal to my value minus the mean divided by the standard deviation, and that has to equal 0.95. So when I calculate this, I need to look at that 95%. So I have to convert that back into a physical value. So going into my table, I have my percent, 0.9, let's see, keep in mind where my 5 is, 0.950 is 1.6449. So that's the z value when my probability is 95%. So from 1.6449 standard deviations and below, 95% of my material falls. So rewriting that in there, that's 1.6449. We want to find the value where that happens. It's going to be exactly 1.6449. So I'll multiply by 10, adding 70, k equals 86.449. So if I were to round that using 3 significant figures, 95% of our crabs are going to be 86.4 millimeters or less, because those are the ones that are being saved. Okay, looking at additional applications with normal distributions. So this last one I just did is I gave you the probability. You would find where that z value was and then calculate all of that. Other times I can still, just like we've been doing, give you the number, and then you have to find the probability. Keeping in mind, of course, as we go through all of these problems, that symmetry, because this is a normal distribution. You have a nice bell curve. So in this example, 1972, the heights of rugby players were found to be normally distributed with a mean of 179, standard deviation of 7. Find the probability that a randomly selected player in 1972 was at least 175 centimeters tall. So for this problem, I want the probability that my value x is greater than or equal to 175 centimeters. So if I want to find this probability, I'm going to convert it into a z-score, and then I'm going to go and find what that probability is. So if I convert this into a z-score, Z therefore equals 175 minus 179 all over 7. So therefore my Z value is negative 0.57. So I want to find this probability. So in order to do this, looking at my bell shape, I want the probability that they're at least 175 centimeters tall. So I want from negative 0.57 up. So I want all of these values. Well, that's exactly the same as, so at this point here, this was negative 0.57. That's the same thing as positive 0.57 down, which is the way my table works. So now I'm going to go to my table and I'm going to find where it equals 0.57. So on my table, 0.57 standard deviations away, as long as I followed my 7 column down correctly, is 0.7157. So therefore, the probability that a player is at least 175 centimeters tall is, so the probability of Z being less than or equal to 0.57 is 71.57%. Okay, so that's finding the percent giving a value. The next one talks about it between some values. I want to find between 170 centimeters and 190 centimeters. So again, I can convert this into my z-scores, find each of those, knowing that my mean is at 179, and I'm looking down at 170, and I'm looking up here at 190, and I'm finding all of this in between. So I'd have to convert all my z-scores, do my subtraction, all of that stuff, which takes a lot of work. Can do. We've done that in a previous video. Or we can put this into our calculator. So if I want the probability that x is greater than or equal to 170, but less than or equal to 190, this is a normal distribution. So normal CDF. My beginning value, 170. My ending value, 190. My mean, 179. And my standard deviation of 7. Type that into your calculator. You get 84.3%. Now, I forgot to talk about your calculator for going backwards. So we're going to go back just for a moment to this last problem that we were looking at. How do I do this in my calculator as well? Because you're not always going to want to have to do it by hand. So if I have to go backwards, if I give you a probability and you have to go backwards and find that k value, find that quantile, you can use an inverse normal command into your calculator. So, again, sorry about the little side note here. You'll use the inverse norm in your calculator. The first value is your probability. The second value is your mean. And your third value is your standard deviation. So when you type that directly into your calculator, it will spit out the value at which it needs to occur, which is the 86.449. So that's the quantile that they're giving you. So you use the inverse norm if I give you a probability and you have to find the value at which that probability occurs and below. So hopefully that kind of makes some sense. Okay, then, last example. I want to find the mean and the standard deviation of a normally distributed random variable x if the probability of x is less than or equal to 20 is 0.3 and the probability of x being greater than or equal to 50 is 0.2. So first thing I'm going to do is it's a normal distribution. I'm going to convert these into z-scores so I can take a look at my table. So the table then, or what I'm looking at, my z-scores I should say, is going to help me find that standard deviation and my mean because those are going to be some unknowns. So to start, the probability that x is less than or equal to 20 is 0.3. So converting this x into my z, it's the same thing as the probability that z is less than or equal to my value minus the mean over the standard deviation, and that equals 0.3. So now what I have to look at is this probability is 0.3. So 30% of my data is from here down. This is 30%. Here's the problem. My table does not do that for me. My table finds from 50% up. So I have to keep in mind, well, what is 30%? So when we look at our z-score for 30%, if you can kind of think about it a little bit, it's about a half a standard deviation away or so. Just a rough estimate. So that's the same thing as taking a look at, okay, now I need to go up here. This from here down, that's going to be 70% of my data. Well, this z-score here is going to be the same. This one is negative because it's a half a standard deviation or so below the mean, whereas this one is a positive 0.5 because it's going to be that positive amount. So we're going to be looking at the complement to my 30 degrees. So in my table, I have to look at what happens at percent, I'm sorry. I have to look at 70%. So 70% occurs at 0.5244. So it's pretty close to 0.5. So this is 0.5244 standard deviations above the mean. So this is actually 0.5244 standard deviations above the mean. Therefore, at 30%, it's negative 0.5224. So this equals negative 0.5244. That, again, is my standard deviations, which is looking at that z-value. So I already know my z is 20 minus my mean divided by my standard deviation equals the negative 0.5244. So that was the first one. So now I'm going to look at my second probability. In my second probability, that's the probability that x is greater than or equal to 50 is 0.2. Well, if I'm looking at greater than or equal to 50, that probability is being 0.2, that's the same thing as saying the complement to it, probability of it being less than or equal to 50 is 0.8. So now I have to look at my table, find where 0.8 is, find where 80% is, and that's going to be my z-value. So 80% is 0.8416. So therefore, this equals 0.8416 when I convert this into a z-value, which is 50 minus my mean divided by my standard deviation. We're talking about the same mean and the same standard deviation. So I have a system of two equations with two unknowns, both my mean and my standard deviation. So I'm going to kind of expand these out a little bit. So writing out my first one, this one over here, is 20 minus the mean equals negative 0.5244 sigma. And then on the other side, that's 50 minus my mean equals 0.8416 sigma. So if I do elimination here, I can directly cancel out my means. So I'm going to multiply one of these by a negative. So I'll make this negative, positive, positive. And when I do elimination here, my means cancel out. And on the left-hand side, I have positive 30 equals 1.366 sigma. And divide both sides by 1.366. And therefore, my standard deviation is 21.96. That's quite a spread. Then I can take that, substitute it back in, and find my mean. In either of them, it doesn't matter which one you plug them into. Maybe I'll use the second one here. So 50 minus my mean equals 0.8416 times 21.96. And then subtract the 50 over, multiply through by that negative. So therefore my mean is 31.52. And if I'm questioning this, I can take my mean, my standard deviation, plug them back in, calculate my z-value, and it better equal the probability being 0.3 for the first one, and taking the probability of it greater than or equal to 50, giving me 0.2. So we just went through finding quantiles, using those inverse norms to do your calculator, otherwise using the inverse norm table, and then also looking at just some real-world applications to them, making sure that you can figure out all of these different things. Systems of equations happen. There's some unknowns in there.